All right. Now recording. So, given that like 2 weeks ago, when we were talking about our our week 4 material, I sort of quickly glided over static, and I said I'd come back to it after the test. It is now after the test, and I will come back to it. It's also a fairly important topic, and because basically, some of you may find working in an object-oriented environment, like a strongly object-oriented environment like Java, you may find it a bit hobbling. You're not able to fully express the sorts of things you want to do with the programming language. Some of you have found this already, right?
Yes.
Lack of global variables, for instance, is probably a sticking point for some of you. Technically speaking, you shouldn't use globals wherever possible, but to not have them available it forces you to figure out how to not use them. It is good to be forced to not figure out how to not use them, but it's still useful to have them every once in a while. So, one of the things that static puts back into the language is that functionality around having global data. So, let's give ourselves an examination of what it means for something to be static. We'll do some programming examples, and then we'll move on to the week 5 material, which focuses on arrays, which hopefully that's a topic that will be, it's sort of intended as a slightly lighter topic for being after the test. Hopefully your pre-existing knowledge of linear data structures will serve you well insofar as you already have that. So, let's talk about, well, static. My goodness.
Gravity.
Oh, thank you very much. Oh man.
Oh,
You know, the marker bit in the middle fell out.
It's on the end of the
ink.
marker.
No, like the core fell out. Weird. Man, you just don't make them like they used to, huh? All right. Is that it?
Wait, underneath the
planned
thick cable.
obsolescence.
Underneath the cable.
The thick cable, if you look under the
Oh, there it is. I can't really, and the problem is touching these things with your hands, it's like, alright. Yeah, that's just broken now. That's okay. Green's the least useful color anyways. I don't even know why I packed the green marker. Nobody can ever see it on the board. Probably just to make my magic marker wand longer, right? Be more to the point to have like 2 reds or 2 blacks or something. Anyway, so, static variables, and also methodes. So, it's always instructive when dealing with a new concept to know what its opposite is, right? The opposite of a static member is an instance member. Now, you may have caught, up to now, when we've been dealing with members in classes, I have very often been using the phrase static variable or instance variable of the class, instance variable this, instance variable that. Instance method is not a phrase that you use so much, but it's that distinction still applies. So, when you're talking about an instance variable, you are talking about a variable that attaches itself to the instance. That is to say, to the instantiated object, or just it must be on an object. So in order to understand the distinction between static variables and instance variables, static members and instance members, you must have a firm conception of the difference between a class and an object. Right? Now, this was something we talked about when we first introduced object-oriented programming, but at this point it's instructive to return to the topic now that we've explored inside of the topic a little bit more. Just like, so I always say that programming is very much like martial arts because you spend most of your time going over the basics. What is a class?
It's a blueprint on what the object is gonna look like,
Okay, and what is the object?
an individual member of the class.
Sure. So the class is a description of an object. On its own, a class does not exist physically. It must be used to create an object in order to physically exist. Right?
You never instantiate a class, you always instantiate an object of the class.
Yes, the object is the thing which is instantiated. The class is the thing from which it is instantiated. Right? So, what static allows us to do is it allows us to associate data and operations with the class definition itself rather than any specific object. So, what that means, effectively, is that you are reintroducing a pool of data which is global to all instances that are instantiated from this particular class. Although it gets even worse than that, because if it's a public static variable, then it's accessible globally from any context through the class name.
So public static void name.
Public static, yeah, so that's a good thing to bring up. So most of us have seen the static keyword most frequently as a part of the main method declaration, public static void main. So the static designation on that method means that you do not require an instance of the class in order to execute the method, which is good because in this case, if it's the first thing being created, there are no existing objects yet, right? The main method of the class which is being run creates all other objects, directly or indirectly, right? It either creates them itself, or it creates things that create them, right? It is the top of the hierarchy. So, when you have a main method, you're saying when you're making main static, you're saying two things. Number one, I can just execute this without having an object, which, fortunately, is that's like a logical condition for it to be executed in the first place, right? To execute an instance method, you require an instance. If you don't have an instance, you can't execute an instance method. Since main must be executed in the absence of any instances, it therefore must be static. So logically, main must be static. Secondly, we are saying, effectively, there is one definition of main for all instances of this class. That's the other thing that static means. It means this class has one of these, everybody shares it, right? So, that's that also kind of makes sense. If you're one second. If you're speaking about like executing a main method, does it really make sense for there to be more than one? Like if you're thinking about, yeah, exactly. If you're thinking about the context of other programming languages, right? Think about how things work. Like, you know, who does like C++? Anybody? Anybody? Most of you guys do Python, right? Most of you. Well, you all did Python. Ostensibly, you all did Python last semester. Python is a bit tricky because, like other interpreted languages, it hides what main is. But
The first line after the debts, isn't it?
No, it's the entire file, actually.
Okay.
Implicitly in Python, if you have the contents of the Python file itself, there's always one line at the beginning that's never stated, which is def main, or more like class main. And then the entire contents of the Python file it's actually, if you want to get right down technical, it's underscore main.
Okay,
Because if you
I
look
see
at
that.
if you take if you type custom definition, it will come out something like main dot my class. If you type something and if you use the type of operator in Python, that's how it comes out. So main is always this file. So the point is there's just one, right? If you were writing a C program and you declared multiple main methods, C would say, what are you, an idiot or something? You know? And that's how it works in most programming
Well, it's
languages.
the entry point to the program, right? You can't have two entry points.
Precisely. Programming is precise and exact and accurate, and we hate ambiguity, right? In the same way that you can't define any function multiply, you can't define main multiply, right? Question?
So you can't overload the main function?
Not usefully. When Java calls it, it will call it with the string array of arguments, one argument. It will use its own default definition of main as its entry point. If you choose to overload main, I guess it'll work, but I don't see what the point would be. If that makes sense. Since we're on the subject anyway of main. I was going to say something else about main. Yes. So usages of main in Java. The Java language allows a main method in every class. The convention in Java is that one of these classes is your selected top level class. The purpose of main methods in every other class is testing the class in which the main method occurs. That's like, there's nothing in the language which requires that. That's the convention among Java programmers, right? Because, if you have a class hierarchy of 200 different classes, say, a large Java program, finding some kind of thread of execution all the way down to some class that's like 6 levels deep inside of your hierarchy, so you can test just that one from your top level. It's a task. It's a task in and of itself just to get there, right? However, if you write a main method inside of that class itself, you are providing a starting point of execution for that class, which allows you to perform, testing operations.
You can just run it individually instead of having to run it through your whole program.
Precisely. Instead of running the class in the context of the entire program, you're running just that class. When you run just a class, in Java the convention is that is a testing procedure, right? You put all of your testing procedures, all of your verification steps, making sure that your class works the way it is intended, you put that there. But, that's kind of neither here nor there. So, with instance variables, you get one copy per object. They do not share data between objects, right? Think about your vending machine class. If I instantiate 2 vending machines, and one has chips and the other has pop, when I assign to the name of one, I do not modify the name of the other, right? If public, Instance variables are accessed through the object name. So you can't access an instance variable through the class name. That would be nonsensical, right? Because again, no ambiguity is permitted. Which object will which object are you talking about? That's the question if you're accessing it through the class. Instance variables are accessible in instance methods. Now this is an explanation for an error probably a lot of you have run into with your main methods. If any of you have tried to create instance variables of the class and use them inside of public static void main, you will have run into a compiler error. How many people have run into that compiler error? Probably the rest of you have, you just don't remember. So the problem is that instance variables cannot be accessed from a static context. So when we are running a method, whether that method is an instance context or a static context matters as to which variables are accessible. So, for example, let's say we have a class, my class. Incidentally, in UML, static members are underlined. So, let's say we have my class with a public static member, count, which is an integer, and a regular public variable value, which is also an integer, sure. And let's say we have two methods, say public get count, which returns an int and is static, and get val, which is also basically the same thing. Right? So far so good?
So all are static.
All are which?
So all variables are static, or
Nope,
No,
only
just
the
the
underlined
underlined
ones.
are like two, or
Count the
This
check.
one is static and this one is static. Count and get count are, this is a static variable, this is a static method. Okay? This is an instance variable, this is an instance method. So when you transform this class dot description into like programming block O vision, right? Normally we would think of my class instances where val is equal to 5, val is equal to 10, etc. Right? You've seen me do this before. Now, we have to complicate this somewhat. We now have to think of them as having names, because all objects have a name, right? So my class A and my class B. Now, we also have to think of the class description itself as something that holds data. This is slightly contradictory to our approximation of the class as a blueprint, right? If the class is the blueprint for a building, and the object is the building itself, then the existence of static instance variables in the class means the blueprint has like some doors and a window and some bricks on it, right? It breaks that metaphor. But if you think of these as containers for data, it works a bit better, because that's what they actually are, right? So, if you think of my class itself, it now contains a variable count. Count being 2. So, You have to think about the context in which a method executes, right? GetVal is is an instance method. That means it runs on the object, right? So, if I say a.getVal, I am running it, let me get a different color. I'm running it in this context, right? It has access to this iteration of value. If I say b.getVal, same thing, except it's this one, it's not communicating with A. So here's a question. Is it possible to say my class.getVal?
No.
It's not. The reason being,
That's private.
There is no wall.
exactly, there's no val variable to access in this iteration. So you are stuck in this data container. It does not contain instance information. So it can't access, you can't use instance methods inside of it. Question?
We're probably about to get to this, but if you use a.getCount for both and b.getCount, they're both the same, right?
Yes. So that's,
They both have this account in my class.
so let's talk about how one uses a static method, right? So these are all usages of the instance method. Let's talk about a.getCount. b.getCount and my class dot get count. Let's see, my class dot get count. I think we're missing a few people, but most of you are still here, so that's good. Ha 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 ha. Incidentally, this one does not work. The other ones do. So, we'll start at the bottom. When you run myClass.getCount, you have that available, right? So, this one works. When we say a.getCount, we are still running a static method, so it is still being run in the static context. So, a.getCount is actually occurring inside of the class context, not the object context. Same with b.getCount. A.getCount and b.getCount are both they're both using this method in the same static context. They cannot access the instance variables of the class, even if you're applying them to an object. Yes?
Just a question, so can we still have a count variable in the object as well? So we have a static and then we still have.
Not if it's static.
Not static, but we can still have, like, we can display different value inside a object.
Having a instance variable and a static variable which have the same name, I believe, would be a syntax error. I believe it would be a syntax error, but I'm not absolutely sure that it would be a syntax error, but I can't imagine Java would let you get away with it. That makes sense. Question?
So is Java in the background just looking at the object A, pulling the class out, and then running the static variable with it?
That's precisely what it's doing. When you are running a static method, the only thing interesting to Java about the object that you've selected is which class it's a member of, right? So these are all synonyms. these all mean the same thing. When you're using, the only difference is if this is a private static, if this is private static information, you have to be in the class to have access to the class. So these two have private access, this one doesn't. But this guy can occur literally anywhere, right? Because in Java, class names are in the global namespace, which is a fancy way of saying you can access any class which you have included in your Java program. The class name itself is accessible anywhere so long as the class itself is public, right? And we aren't really dealing with private classes, right? In theory, if you want to extend your knowledge of private versus public to classes, you can do that, but for the purposes of us in this course, we're really only talking about public classes, right? Each class gets a file, each class is public, which means that they're all accessible everywhere, which means that their static information is accessible everywhere. This basically puts global data back into our program. You had a question?
Yes. So can we still access counts if the method is not static? If the get
Yes.
count is not static?
You can access static information from an instance method, but you cannot access instance information from a static method. And it kind of gets down to like who knows that who exists. So the object always knows that the class exists and where to find the class, right? But the class is actually never, like, you can do this yourself if you want to, like you can put this in code if you really want to, but the default position in Java, this thing has no idea how many objects have been created from itself or what their addresses are. It doesn't know where to find its own objects. Objects know how to find the class doesn't know how to find the objects, right? So there's no way for the class to get at the instance variable information. But the objects always know how to get at the static information in the class because they were created from the class. Yes?
Sorry, so I mean to say, like, if the get count is not static, can we still use get count through the object?
If get count were not static, presumably it would be accessing count, which is static. Is count is still static in this instance, or in this example? Yeah, so that would still work. Yes.
So is there any reason why get count has to be static?
Because I was doing a teaching example of showing how static methods work, basically.
Okay, but we can have it without get without the static.
Yeah. So in this case, get count works or does, it works or it doesn't work. Pardon me. Let me rewind 5 seconds. This particular method would work as an instance method or a static method. Since all it's doing, it's a getter, all it's doing is accessing static information. You can do that from an instance context. This does not have to be static to access that information, right? However, if it's public, that means that you can still do encapsulation with a method that does not require an object, right? So we could call myClass.getCount. We could have properly encapsulated count variable, right? And this would still work, and we would not require any declared instances of my class. Does that make sense? Are there any other questions from anybody in the class? Yes. Or
Here's a quick one.
Yeah.
I just want to confirm, if it is a private static method,
Mm-hmm.
you can call that from an object, but not the class.
I believe that's how it works, yeah. We'll test it. Question?
Can we set accounts in my class A or my class B?
Yes, both my class A and my class B will have read-write access.
Rewrite.
Yeah, you
So-
can
so
read
you
it and you can
cannot-
write to it. Hmm?
You cannot directly set accounts in my class A or B.
So this is why I'm saying that static is kind of like how they do global information in Java, because A, B, and the class itself all have the ability and permission to read and write count.
What if I want to different, like I want to, my class A have account 5 and my class B have my count 6?
Make
I
them
set-
instance variables.
Yeah,
Yeah.
so I can make instance variable in my class A.
So if you want the count variable to have different values in class A versus class B, then you are talking about an instance variable, not a static variable.
But if there's a static variable, can I set static variable account to my class A and B?
If it's a static variable,
Mhm.
it is shared between these two classes.
So I cannot set a new account?
No, you cannot write the program such that class A, object A and B will have different values of count. Because, if you were to do that, you're not asking for a static variable. That's like, you're asking for an instance variable, but you're calling it a static variable, which is a mistake, right? That is how instance variables behave. If I had, I have this value instance variable, it does have and hold different values depending on what object you're in, right? Value 5 over here, value 10 over there, right? But that means that it must be attached to the object, not to the class. If you're attaching it to the class, there is one copy for all objects, right? Which means it can't have a different value for every object, right? Because there's only one of them, and they're all referencing that one piece of data. Does that make sense?
Yeah.
Yeah. So yeah, I'm glad you asked that question, because that's like kind of the whole point. Good. So, let's see here. Okay. Let's load up IntelliJ, shall we? Okay, so IntelliJ project. Just gonna set that to Darkula, because of course I can. There we go. Good. So, for this example, I will declare two classes. One, roughly analogous to this guy, Number 2, some main class with a main method that uses the other one. So, let's make main give it a main method. There you go. And let's make a new class. Let's call it goblin. So, instance variables are properties of an individual object of the class. So, when we write an instance variable, in this case we are talking about a property of a goblin. When we talk about static variables, we are talking about properties of all goblins at the same time. All goblins put together. So, what is a property that a goblin would have?
A name.
A name, sure.
Height.
Height, sure. Gold, goblins like gold, right?
Generally green skins?
Yes, particular shade of green skin, yes. For now, let's just say we have a public string name and a public int gold.
I got a good one.
Public. Java is a terrible language for spelling mistakes. Ha ha ha. I don't know how many times I've left the L out of public in class, which makes a funny word. So,
I don't get it.
second, static. Properties of the class of goblins in general. What are some things we can know about the goblins? Registered trademark.
Alignment.
Yes?
The quantity of goblins.
Sorry?
The quantity of goblins.
The quantity of goblins. Yes, that is a property of the goblins. So, private int number. Or perhaps, horde size, I don't know. Goblins, I think, are more like in small bands and not so much in hordes. Depends on, where you're talking about them. Yes?
Now Boolean, that's if they're hob or not?
Yes. Well,
Or is
see,
that a different race? What are we?
I mean, we could talk about hobgoblins as if they were I would personally probably put them in a different class. And besides, if you're making an individual decision about whether a goblin is a hobgoblin or not, are we talking about a goblin or all goblins? Right? That would actually be instance data. We would say public bool is hob. Doing too much C# lately. Yes?
Did you made a name gold, like public on purpose and number?
Oh,
Right?
no, I was, I made a mistake because I was thinking about something else. Sorry, I was thinking about Haagen-Dazs. So, thank you for correcting me. So yeah, so we've got 3 instance variables, name, gold, and is hob. And we've got 1 static variable, which is the number of goblins. What is another property that we can think of about the category of goblins in general?
Weapon.
Well, here's a question. Do all goblins have a weapon, or does each goblin have a weapon? So that would again be instance data. What do all goblins have?
Alignment.
Alignment? Yeah, sure. that would be one. It depends on how how recent your copy of the monster manual is. I would say, in recent
From
editions.
1976.
Yeah, in recent edition, Goblin is like a playable race.
Oh, yeah, yeah.
Like,
That's okay, that's 3. They
Yeah.
started that in 3.5.
yeah. Well, anyway, if it's a playable race, then in theory you can have like
Yeah.
lawful good goblins, which just
Well.
doesn't make any sense at all.
5th edition screwed all that up.
Yeah. But anyway, enough talk of that nature. We're losing the rest of the non-D&D playing class. Yes.
Gender?
Is that a property of a goblin or the goblins? Again,
Yeah.
see, it's tricky, right? You have to think about much more general properties when you're talking about static data. Yes.
Penchant for ambushes?
Sure.
Does stink.
You could, okay, but let's extend the video game metaphor a little bit, right? And I know I'm talking primarily to people who've, played video games, but hopefully everybody has some touch point for this. When you have a monster in an RPG, typically they will have a fixed stat block, right? Particularly if you have a stat block in the kind of Dungeons and Dragons sense where you don't really scale the stat block as you increase the level of the monster, like you don't really have monster leveling. It's more like a Dragon Quest style where a monster is always a fixed difficulty no matter, where it appears in the game. But so if we are to say that a goblin has, all goblins have a strength stat of, 9 or something like that, right? That is information which pertains to all goblins, not some particular goblin, right? Yes?
I was gonna say a good static one would be average age.
Yeah. See, aggregate statistics of the individual instance variable, that's correct. It's kind of like not what I was going for the example, because it's still conceptually tied to the instance, the individual instances. But then again, so is number, right? It's the number of instances. But yeah, okay. Or if we tie it back to the data that we already have existing, we could say public static double average gold. The average amount of gold per goblin, right? And in order to calculate average gold, public static int total gold, which is the total amount of gold held by all goblins, right? So in theory, you don't even need one for average, you don't even need to hold average gold as an instance variable itself. If you know the total amount of gold held by all goblins and the number of goblins, you can easily calculate the average gold per goblin. It's just division, right? So, that's a good one. I like that one. Total amount of gold per goblin. That's nice and easy to implement. So, does this make sense? Are you starting to get the idea? Hopefully. Yes?
Just a quick question. So if the static variable is private, can we still access them through class names and the object names?
I don't believe so, but we're going to test it. So any questions so far? Hopefully none of the questions are, what is a goblin? For those of you who may not be aware of what a goblin is, it's a smallish, greenish humanoid with pointed ears, which is a common feature in European fairy tales and that sort of thing. It's kind of a stand-in for a little mischievous spirit that, is also popularly adopted in modern fantasy fiction. So, Any questions? Shall we proceed? Oh, yes.
I think I got one more. Food stash, like the food hoard, for a total group of how much food they all have.
Yes. So here's a question, though. Do all goblins exist in one horde or one group? Right? So in theory, like quantity of food in a food stash would be a property of a group of goblins, with not necessarily all goblins. Right? So, you know, think about the map laid out, right? With various goblin encampments, right? We're talking about properties of all goblins in all encampments all at once. If you want to make another class for like goblin encampment, which has some number of goblins assigned to it, we're starting to get into like assignment 6, 7 territory actually. Like in actual fact, we're going to be getting there, don't worry, when we talk about the difference between association and inheritance. But anyway, yeah, you're on the right track though. That would be a static property of, well, or it may be an instance property of the camp. Yeah, it would be an instance property of the camp, but your brain is going in the correct direction, if that makes sense. Any other questions, comments, concerns? Okay, so now let us instantiate this information. So when you are creating initial values for static variables, it's important to know when things are used, right? Instantiation provided here in the declaration for a static variable, that executes once when the class is loaded. So we do not declare, or we do not initialize static information inside of a constructor. What does the constructor do?
Use an object.
It creates an object, right? Is the constructor called several times?
Maybe.
Presumably, once for every object that you create. So, if you put the initialization of static members inside of a constructor, those numbers get reset every time the constructor gets called, which means that this data gets blown out every time the constructor is called, which is probably not what you want, right? Rather, we initialize them up front outside of the constructor. So, let's just create a constructor, right? Public goblin taking string name, int gold, and boolean is hob. This dot name is equal to name. This dot gold is equal to gold. This dot hob is equal to is hob. Just the way that you would expect it to go so far. So, another way of thinking about static variables is a kind of an operational way of conceptualizing them. Static variables are typically used for two purposes. Number one, constants, right? You can imagine in the math library, pi is static, right? You don't need a separate definition of pi for each, instantiated item from the math class, right? Typically everything in math is static, but you can imagine, if you had a class representing gravitational attraction between celestial bodies, the universal gravitational constant being universal applies to all instances of that class, therefore would be static. Constants are often static because they don't need to vary between the objects, unless they do, in which case they would be instants. Right? The second purpose is aggregate data and metadata. Right? If you're keeping, so do you guys know what I mean when I say metadata? You know what metadata means?
Data about your data?
It's data about your data. Yes, very good. I haven't done that one in this class yet, have I? No? You get it? Yeah? I'm so meta, even this acronym. If you make an acronym out of it, what does it say?
Meta.
Is meta. So, I'm so meta, even this acronym as an acronym, it's ISMETA, right? That's what metadata means. Like that's the best, most concise definition of what it means, what the term meta means. It's something above, in between, it's about, pertaining to something else. It's like, take for example the Greek word metamorphosis, right? From our definition of polymorphism, we already know that the Greek morphos means shaped, right? So metamorphic means changing shape, right? Or it's between its shapes, right? Somehow supering its own shape. So, anyway, so metadata, something like the total amount of gold held by all goblins and the number of goblins in existence, we can consider this metadata, which we are keeping track of, about the goblins that we have created from this class, right? It's reasonably easy to keep track of this data. When we create a new goblin, this dot number of goblins increases, right? And when we create a new goblin, the gold that this goblin is given, this dot total gold, is increased by the amount of gold that this goblin receives. And of course, because it's a static because it's static, you don't need this. It's like, it wasn't an error, but it's not necessary to go through the object reference. Remember that this is an object reference. It's a reference to this object, right? So, it's not necessary if it's static, right? Because you don't necessarily need to go through an object reference because it's static. So, does this make sense so far? So just to prove to you, oh my goodness, just to prove to you that I'm not completely crazy, let's write a couple of accessor methods. So public static int get number. Return number. So far, so good. What if we get rid of static? still works. To your point, it doesn't matter whether it's static or instance, since the information it's accessing is static, both are capable of that, right?
So there is no point of having static methods?
There is still a point in having static methods because it modifies how the method can be accessed. If it's an instance method, you are required to use one of these two forms. If it's a static method, you may use all three of these forms. Does that make sense?
Yeah, thank you.
So, let's compare this to public static get gold. Return, public static int that get gold. Return this dot gold. So, public static int get gold, return this dot gold. First, is gold an instance or a static variable? It's an instance variable. The static keyword places this method in the static context. If we are in the static context, does this exist? It does not. This is a reference to an instantiated object. Because we are in the static context, there's no reference to the object because the object doesn't exist in this context. So, that's why I'm getting a compiler error here. Goblin.this cannot be referenced from a static context. It's an instance. This is the instance. So I delete it, and I'm like, oh my goodness, I still have an error. Return gold, still a problem. Non-static field gold cannot be referenced from a static context. So, the gold is a property of each individual goblin. Since get gold is static, that's where the origin of the mistake is, this here. Since get gold is static, you must be able to run it without having an instance, right? Gold only exists in the particular instances. So, this doesn't exist. Instance variables don't exist in static contexts. Does that make sense?
Yes.
Hopefully? Okay, good. I think we've beat this dead horse sufficiently. Perhaps we can move on to week 5. Yeah? Sehr gut?
Yeah.
Yeah? Good. So, to fix this, delete static. One final note on all of this. That fix doesn't work when it's main, because main is expected to be public static void main. So, here's your trick for getting around this in main, alright? This is practical programming. It's okay for Goblin to have a public static void main for testing, sure. If you try to say this dot gold, right? Same problem. You can't access instance variables from main. So, what can you do?
Make an accessor method and use that instead?
Nope. Any accessor method that you use would have to also be static, and static can't access instance. This is a clever trick. All right? What you do is you declare an instance of the object inside of its own main method. So goblin test is equal to new goblin. Goblin, what's a good goblin name?
Garablock.
Boblin.
Bobley?
Boblin. B-O-B-L-I-N.
Boblin the Goblin. Love it.
My blog.
100 gold, and his hob is false. Just a regular goblin. Right there. So now we've done a clever little trick. We are not accessing the instance parameters directly. We are creating a static instance. Ha-ha! Doing both at once. So, what you do is inside of my class, you declare a little my class C, and then that can have a value. It's different from any other ones that have been declared, and it only works for main methods. Like it's only effective in a main method, because the main method is the top level thing anyways. But if you want to say test.getTheGold, that is not a syntax error, because you are not referencing an instance variable. Local variables declared in static contexts are static. So this is a static instance of the same, of a static object made from the same class that the main method is in. Slightly, very slightly recursive. Yes?
Does that make Boblin the Goblin God? Do
Um,
goblins know about Boblin?
I don't know. I'm not sure what the application of static to instance status to godhood would be. In theory, it depends on your definition of divinity. If you consider the template from which all goblins were created to be the original goblin, the progenitor of the race, if you consider the progenitor of the race to be the same thing as the god of the race, then yes, but it depends on the religious structure of the goblins. Yes?
Because gold is a public variable, you could just do standard out print line test.gold.
Yep, totally.
Okay.
Like right now we're calling the method, not really doing anything with it. Sout test.gold. Save that. You can see goblin has become executable. I will even run it for you because I like you that much. There you go, 100 gold. Right? But notice, we are in a context where the amount of gold has been provided. Without that, no amount of gold has been provided, therefore it doesn't make sense to access it. Right? Make sense? Do we feel we have a decent handle on what it means to be static now? Like, honestly, this is one of the trickier concepts. This and inheritance. These are both like tricky object-oriented ideas, but if you understand them, like, it really does elevate the amount of like effective programming you can do. And I would even say, like, you can't really be an effective Java programmer without understanding these sorts of distinctions, because it really is the difference between a class and an object. And if you're going to be an object-oriented programmer, you should understand the difference between a class and an object. And it hasn't really yet, like, it hasn't come up as viscerally as it has here. But anyway, let's talk about arrays, shall we? Okay. All right, everyone. I have a joke for you. Is everybody ready for my terrible joke?
Sure.
Okay. Let me just get it here. Okay. Why did the programmer quit his job?
Because he didn't know exactly where to program.
Nope, because he didn't get a raise.
That's not the worst joke I've heard today.
Yeah.
Really?
It's only like 9 o'clock in the morning. Okay, maybe I can do better. Okay. What do you call a cow with no legs?
Unmovable.
That's pretty good, but no.
I know the answer.
Ground beef. What do you call a cow with 2 legs?
Bean beef.
Lean ground beef. What do you call a cow with all of its legs?
Cow.
Well, yes, but high stakes. What do you do with a dead chemist?
Hide the evidence.
You bury him. Barium is a chemical element. All right. I think that's enough nonsense for one day. Silly, silly, silly. All right. All right. So, arrays. I want arrays. Ha ha ha. So, in Python, you will have dealt with lists. Yeah?
Yeah.
Hopefully, to a reasonable degree. Did they do 2-dimensional lists with you guys? Good. With like nested loops?
Yeah.
Even better. Fantastic. We're already on good footing then. So, arrays are similar to lists in many respects. It's kind of one of these things where, like, if you're squinting at it, an array looks very much like a list. You have to be looking in detail to be seeing the differences between the two. But there are some very important differences between arrays and lists. And at this point, I have to talk about memory. I'm sorry, but I'm really an architecture guy at heart, so I have to talk about how computer memory is organized at this point. So, when it comes to so both arrays and lists are considered linear data structures, right? Because what we are effectively doing is we are taking a series of numbers, 0, 1, 2, 3, 4, 5, 6, 7, and we are mapping data to these numbers. If you wanted a high math way of saying this, an array or a list, what they both do, they are mappings between the natural numbers and some other elements of some other set, right? The set that they're mapping to, that's the data type of the array. So, for example, I could have, most typically you do an array of integers, but you could do an array of booleans, for example. True, false, true, true, false, 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 true. Something like that, right? So, from the programmer's perspective, that's what you see, right? You see a linear arrangement of data. But, depending on how this data has been arranged in memory, you get different runtime characteristics and memory usage. So, there are two main approaches here. The first and more direct approach is to take this and just drop that in memory itself, just like that, right? You take a big old chunk of memory, you put data in it linearly, and that's your data structure, right? That is an array. The alternative view is the list. In a list, each one of these get stored in a random chunk of memory, and they link to each other. So, in an array, if you view your memory, you declare one continuous chunk of memory. What is it? True, false, true, true, false, 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 true. There. It's one continuous chunk of memory with a starting address. Right? The alternative is the list. It's very important to say at this point, lists are not better than arrays, and arrays are not better than lists. Right? They both have their advantages and disadvantages. When we examine the structure, we should be able to pick out some of the advantages and disadvantages. So, in a list, or let me say, the array itself points here, right? In a list, the array itself points to an element containing the first element and a pointer to the next element. So we end up with, how many we got here? 8, 2, 3, 4, 5, 6, 7, 8. So this one points to the next one, which is a false, true, true, false, 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 true, and then this one points to nothing. Does this make sense? So these things are pieces of data that hold memory addresses. That's what a pointer is, right? You can think of it in Java in terms of object references, because they're basically the same thing. But they're like object references are Java's attempt to tame the pointer, but that's okay. So here's first advantage, right? When you've arranged all of your data linearly, not only does it look neater, you can access the individual elements here very quickly, right? If I say A at 3, what I am actually saying is access the data at address A with offset 3. Implicitly, this gets modified by the data width of whatever you're holding. So, with offset 3, 1, 2, 3. It's actually the fourth element, right? So, A at 0 is A with offset 0, which is that one. This is why we use 0 indexing. If you ever wondered why numbering on arrays starts at 0, it's because the index operator is not indicating the number, like the numeric placement of the data. It is indicating the memory offset. This actually gets turned into an arithmetic calculation. It's A plus 3 times W, where W is the width of the data, right? In an array, the first, the memory cell pointed to is the address of the array. So A plus 0 times W is just equal to A, which is the address of the first element. That's why we use 0 indexing. But this means, goodness me, oh, that's so annoying. I was just working up a good rant too, and get interrupted like that. It's terrible. So, arrays are fast, right? To access the third element, you perform this calculation, then you get to grab the data, right? To put it in algorithmic terms, access is a big O1 or constant time operation. It always takes the same amount of time to access any element of an array, no matter where it's positioned in the array. The same is not true of a list, and here's why. Let's say we wanted to access the third element of this thing. Because the placement of each node is random in memory, there's no way of calculating where the next node should be from the previous node's position. If that were the case, we wouldn't need the pointers. So instead, for a list, we must follow the line, we must follow the breadcrumbs. We have to follow the pointers, right? So to access the third element, we must go 1, 2, 3, 4, there it is, right? Access becomes proportional to the size of the data structure, where the size of the data structure is n, big O of n. So access for an array, very, very fast. Access for a list, there are slower algorithms than this for sure, but that's not fantastic, right? So you might be saying to yourself, okay, so arrays are better then. No, because there are some things that arrays are very bad at. One thing that arrays are very bad at is growing and shrinking. Well, shrinking is not so much a problem, but growing is really strongly a problem with arrays. So with arrays, you know, we've got this dinky little array containing 8 elements, and they're all Booleans, very, very small in memory. Let's imagine we had a slightly beefier array. Let's say we had 10,000 elements, which you could easily have on a large program, right? 10,000 elements takes a big chunk of memory. What happens if you have to add 10,000, you have to add one more element to it? Well, because it's so big in memory, right? The position, and it's really the position at the end that matters for this, might already be occupied, right? So it's not always possible to just carve off a little bit of unused memory at the end of the array and add that to the array, which would be our natural solution. It's like, oh, if you need more space, just like declare, you know, take whatever space is at the end, throw that in the array, or throw that in the array and everything's fine. It might be occupied. And the larger it gets, the more likely it is that that's going to be the case, right? And especially like if you have to request a whole chunk of an array all at once. So, what do you do in this case? What does the operating system do? Any guesses?
Makes a new array.
It actually does, yes. So, in memory, if you request an expansion to an array and you don't have the room for it, what it will do is it will scan through the memory system looking for a spot that's big enough, and when it finds one, say down here, oh wow, that's terrible. All right. It looks for another spot that's big enough, and when it finds it, it says, okay, this is where I'm copying into, and then it must copy every single element of the old array over. And if that's 10,000 elements, that's 10,000 copy operations. So, expanding an array, adding one more element to it, is a linear operation. In the worst case scenario, it takes as much time as you have elements in the array,
The last one.
right? Compare that to expanding a list. Let's say we wanted to, the best case scenario is adding something to the end of something. So let's do that one first. All you have to do is find a tiny little chunk of memory, the size of one node, erase this null pointer, point it to the new element, and you're done. Constant time operation to insert. Question?
When the computer makes a new array, does it delete the old one automatically?
Well, it's kind of funny. When computers deallocate memory, they don't actually clear it. So it's not overwriting this data. It's simply saying this now belongs to no one. This is free data again. And the next process that comes along will just overwrite it and use it as needed. But yeah, computers, you'd be surprised. The memory system doesn't actually overwrite the memory with zeros to clear it, because that takes an amount of time proportional to the amount of memory you have to clear. And the computer's like, it's not necessary to do so in most cases, because data only makes sense if it's in context, right? If you have a random ones and zeros hanging out in the middle of your memory system, nobody has any idea what those mean. So like it's useless. Yes?
2 questions. So in the array, if you want to expand it by 1, for a short amount of time, at that original array is a gigabyte, you're going to need another gigabyte in memory as it copies it over.
Yes, at the time of copying, you will require.
And then it'll free up that first array.
I will say 1 gigabyte is a pretty friggin' enormous
Yeah,
array,
but
but
just
the
as
point
a-
is made, yeah.
And for the list, if you want to add a new item to the list, you have to go all the way through the list and find that last item, and then extend the string before
So
you can add an item.
that's the caveat. It's big O1 if you know the point of insertion.
So if you have to start at the start, then it's
Yeah.
N again.
Yeah, if you have to find the point of insertion, then that's why with lists, typically you don't add to the tail, you add to the head.
That's much faster.
That's much faster. You don't have to trace through here. You don't have to use the known position of the last one. Though if you wanted to, you could use a thing called a circular list. So a circular list is a list where the last element points to the first one. And so this is a singly linked list. You also have lists that point bidirectionally. These are called doubly linked lists, in which case, like the problem with a singly linked list, right? If you're going this way, if you know the position of this node, there's no way to get here without retracing, right? Because you can't go backwards. But if you have a doubly linked list, then you know the position of the previous element, so you can go backwards and forwards with freedom and ease. And if you do that in such a way that the first element links to the last and the last to the first, you have what you call a circular list, which means that you always know the position of the last thing. It's always one off the first, which is still considered a constant time operation because it's not proportional to the size of the data structure. But that's, neither here nor there for what we're talking about for today, though I love all of these questions. Question? Nah, never mind? Okay, yeah. So, hopefully this gives you some kind of idea or flavor for the difference between this is what you were using in Python, this is what I'm about to teach you how to use in Java. Yes?
If it wants to make a new array and it can't find enough memory, it just gives you some sort of exception.
Yes. It's rare these days because of the amount of memory we have available, but in lower level languages like C, where you have to do these sorts of operations manually, you always check your memory allocation operation to make sure that the memory was actually allocated and that you didn't get a void pointer back, because if you try to dereference a void pointer, what you end up with is a segmentation fault, which will crash your program. And depending on where the segmentation fault occurs, it might crash the operating system if the operating system produces one. Yes. Well, it's a bad thing, yeah. And this is another reason why Windows is inferior. Because, again, basically, this type of pointer operation is like, this is the bookkeeping you have to do if you're programming in very low-level languages like C or assembly. And if you're just kind of not a very, like, it's not even necessarily like skill or talent or innovative vision. You have to be an accountant for memory. And if you're not an accountant for memory, you shouldn't be programming an operating system, basically.
Yeah, that's fair.
I mean, I like to think that a lot of my positions actually aren't that controversial if you think about it the right way, but like, that's fine. Whatever. So the question probably everybody but 4 people in the room is asking is like, he's gone on for a long time about this subject, which seems unrelated to, what we're actually talking about here. So,
Is this on the test?
no, that bit won't be on the test. So it's necessary. I viscerally have to go through that though every time the issue of lists versus arrays comes up.
Or develops,
Yes. It's involuntary. Yes.
So does the last element in the list point to anything?
In a singly linked list, no. In a doubly linked list, no. In a circular list, yes. It'll point back to the first element. That's normally like how you tell that you're at the end of the list, is that the pointer to the next one is blank.
Okay.
So, arrays are not lists, though they solve the same problem. In Java, arrays are objects. They store indexed elements starting at element 0. Arrays can be processed easily using a special kind of loop that we will see. Java calls it an enhanced for loop. Everyone else calls it a for each loop. So if you know what a for each loop is, we're going to study how to do that in Java. I think that the term enhanced for loop is stupid, and that Java is stupid for using it. I like Java as a language, but like, it does sometimes get a bit verbose. You know, it's a for each loop, gosh darn it. So, some important differences between arrays and lists, now that we know what those two words mean. Arrays are fixed in length. They can be redeclared, but it's a process. Arrays are fixed in type. In order to be able to calculate where each of them goes, they have to all be the same width. Therefore, they must all be the same type. So, in Python, a list you can put anything you want in there, which is very Python. It's like, oh yeah, you can throw a string in, you can throw a double next to a string, it makes perfect sense to us. But what Python is doing in the back end is like all kinds of intensive pointer work that
That's why
nobody
it's so
knows.
slow.
Exactly! That's why it's so slow. It's like, oh yeah, your number can be as big as you want it to be! And meanwhile, the memory system's like, stop it already! You don't need that many zeros! So, anyway, arrays are fixed in type. When you declare an array, you declare it with a type. And you should be used to this in Java by now. Any stepping outside of that bound is a type violation and a game-breaking bug. Arrays do not support the slice operator. You guys studied the slice operator?
Oh
Yeah,
yeah.
you don't have it.
That's the best thing in Python.
Yeah, it's not bad. It's pretty nice syntax for it, I must say. But, You don't have it.
Java has string slice, doesn't it?
It does, yeah. You have a string slice operator. Like, it's not that you can't slice, right? It's just that you don't have the nice Python syntax for it, right? Yes?
So, to me, it seems easy to just cut up an array, considering they're all beside each other.
Yes.
You just make a new pointer, and then make the other pointer so that it's small.
Java doesn't really like you thinking about pointers to arrays. It would prefer you to like declare a new array and like copy stuff into it and that sort of thing. Like, when you guys see the list of available methods, you'll see what I'm talking about, right? Because arrays are objects, and objects have methods, so you call methods on arrays.
But arrays do not have methods.
Oh, wait, what? Never mind. I'm thinking about array lists. All right, yeah.
Disregard that last bit.
Disregard. Back that up about 10 seconds. We'll go forward from there. Strike that, reverse it, thank you. Arrays do not have methods. I don't know if there's much more to say about it than that. Later on in the course, we will be studying the array list, which, you know, given my explanation here, it's like, well, how can you possibly be an array and a list at the same time? And the answer is, you are an array in the back end, but you implement the interface of a list. So that's what an array list is. We'll be talking about that a little later on in the course, right towards the end of it.
It's an array mullet.
Basically, yeah. Basically, when you're working with arrays, you should be thinking in terms of primitives, right? You should be thinking, I am working with a collection of integers. They therefore behave as integers. I am working with a collection of doubles or booleans. Or even, I am working with a collection of strings. So each of these individual strings I can use string methods on, but the collection of strings itself, that's something I have to deal with in terms of like primitive array operations. Am I making sense so far? Is anybody completely lost? Anybody partially lost? Anybody feel like they're finding their way back into the conversation having previously been lost? Good! So, creating, question.
Do we have to fix the length of array? at
Yes.
time?
The length of the array must be fixed at the time of the declaration of the array.
Can't we just make it empty array?
No. Well, you can, but then it's just a reference to an array and not actually an array. Right? So if these are all you have, you don't have an array yet. You have a container that will eventually hold an array, right? If you declare the array itself, it must be declared knowing how long it is. Because, think about the memory, right? You can't declare some like open-ended amount of memory. It must be a fixed amount of memory, right? That's how a computer works. So, to create the array itself, A is equal to new int array size is specified. There are a couple of alternative ways of doing this. All of them, you get the information out of it, how big is this array going to be, right? Basically, you've got this one, which creates an array filled with whatever the default value is for that data type. What's the default value for integer? Take a wild guess.
No.
That's right, it's 0, not null. Haha, okay. What's the default for a string?
No.
It's null and not empty string. There's a difference between null and empty string. Even though an empty string doesn't really contain anything except the null character. There's a difference between the null character and the null primitive. Null is actually it's a literal. The null literal is different from the null character inside of a string, which is what the empty string is. So when you say, string C is equal to new string, what do you get? You get a string with something in it. When you just say string C, what is the value of C? It's null, because it's an object, because it's an object reference, and object references default to null. Not to an like, in order to get an empty string, you would have to instantiate the string without having instantiated it. It doesn't make any sense. Yes?
I'm gonna use the word pointer because that's what I'm used to, but it's
Yeah.
pointing to a place in memory.
Yes.
And there's something in that memory to hold it.
No, it's not pointing to a place in memory. It's a slot for something that will point to something in memory.
So it's just the pointer that's in memory, it's not pointing to anything.
This is how it works. If you declare string S, just like that, right? You create a slot in memory that holds a pointer, that holds no pointer, that holds a null pointer, right?
Right.
If you say S is equal to Bard, then new memory is created. This guy is the null pointer is overwritten, and then it's pointing to the space in memory where the characters are stored.
Okay, so you're storing where the tail is and then the head's made when you declare something.
So you're storing where the tail is and the
It's
head's made.
the tail of the pointer and the head of the pointer. The head of the pointer is where the new memory is.
In terms of the arrow. Yeah, this is where the tail will go, that's where the head will go. Yes.
Okay, so you only store the tail and then the head's made when you declare something.
I don't think that's a useful metaphor, because what this is, like, that's giving the arrow too much credit. What this is like a memory address, and then you just store the memory address,
Okay.
right? The arrow is just a typographic convenience. If that makes sense. So, you just store the memory address at which the string has been stored in the pointer.
I'll bug you later.
Okay. Question?
Mixed array would have to be a string by when you define it.
Sorry?
If you had a mixed array that had numbers and letters in it, it would have to be stored as a string.
Yeah, basically, you'd have to pick a data type that could store the information you want, right?
How would you pull them apart?
Well, you'd have to, like, as you were going through the array, you'd have to test the individual characters, see if they're numeric or if they're alphabetic, and then do different operations based on that. But the strings which are stored in, like, if you want to put numeric and character data in the same array, it is possible by using this guy. But again, you have to crunch everything down to one data type.
Okay.
Does that make sense?
Yep.
Cool.
Probably a for loop to get them all back out.
A for loop or an enhanced for loop. So, honestly, if you're having difficulty with the concept of the enhanced advanced for each for loop, just use this one. The problem, okay. I have to remember that you guys are coming from Python. So, the Python for loop isn't a for loop, it's also a for each loop. This is a for loop. A for loop is a while loop with pretensions. It's a while loop with delusions of grandeur.
In Python, the for loop is the range function, is it not?
Well, the range function can be used inside of the for loop in Python. Is that the way they did it with you guys primarily?
Yeah.
For I equals whatever.
Oh, it's a
For I
lot more
range.
flexible than that. So in Python, let's say you have an arbitrary data structure like a dictionary, right?
We can do those.
Well, let's say you have list is defined as 1, 3, 7, 2, 5, right? For E in L,
Yep.
right?
Okay.
On each iteration, E is the next,
Yes.
whatever the next element is in L, you iterate through all of the elements. This is a for each loop.
Okay.
even though it's called a for loop in Python. In every other programming language, almost every other programming language, what is meant by a for loop is this. All right? And we already touched on it when we talked about loops back, a million years ago at the beginning of the semester. But since we're actually going to friggin' use for loops for their intended purpose, because we're now talking about arrays, it's useful to review what a for loop actually is and does. So, the for loop does three things. It declares the loop variable, it provides the loop condition, and it modifies the loop variable for the next iteration. It does this compactly on one line. These operations are, most of the time, the operations you would be performing anyway in a while loop, right? The equivalent of that thing right there, that for loop, as a while loop, would be int I is equal to 0, while I is less than a dot length, contents a at I is equal to -1, I plus plus. This is the while loop, that's the for loop. The reason to use a for loop is because people often forget this bit, right? If you forget this one right here, you are in an infinite loop, which is a game-breaking bug. So the for loop, by requiring you to provide all three of these, is protection against your own human stupidity and the fact that human beings forget to increment their loop variables, right? So, most of the time, when you're using an array, you will be doing something like going through every element in the array and doing something. In such cases, you will often be using this exact for loop, right? This is the for loop that iterates through every element. Does that make sense? The for each loop is a contraction of that. Question?
That's just gonna set every element in A to -1.
Yeah.
Okay.
So, the purpose of this loop, as you point out, we have an array of integers declared up here. We initialize that to be 50 elements in size. That actually sets the memory, right? This loop goes through every element in A, setting the values to -1. This is necessary if you want the initial value to be something other than 0. If you want the initial value to be 0, Java does that by default, so you don't have to do it manually. Save yourself some time.
So A
yes.
doesn't exist as a thing until you're like A equals new int.
Correct. Until you've done this, it's a null reference.
That's just a setting of a spot in memory.
Yeah.
Could be.
Yeah.
Okay.
Any questions? Any other questions? So, here's a quick syntactic point. Where are my curly braces at?
It's only one line, so you don't need them.
It's only one line, so you don't need them. Very good. So let's examine this one. Very similar. Notice two things. Number one, we're actually reading our initial values for the array in from standard input, right? So you could, in theory, be running a user interaction to populate your array. I think that would be a very poor use of user time, personally, but whatever. We're learning. Who wants to sit there and enter 50 entries into an array, right? We've got other things to do. But anyway, notice another thing though. Here, we've got a max size variable. So This is an important point which is often overlooked. This does not have to be a literal. You can dynamically choose what the size of the array is, but the size does not change after declaration. So if you want to, take, how much time we have? Okay. Here's an array operation called take, all right? Let's say we have 2, 3, 4, 5, 6, 7, 8, 9. Let's say we have an array like this. The take operation takes the first n elements. So take 4 takes the first 4 elements and returns the array 1, 0, 1, 2, 3, right? The size of the output array is equal to the input parameter. So if we take n, take int n, where we declare the array, out, so int array out will be equal to new int array of size n. Right? We declare only that much memory that we need for the result. Take is easy because you know how big it's going to be when you're finished. Other operations are tricky. If you're performing this type of operation and you don't know what the size of the output array is going to be because of the operation, like for example, a filtering operation, right? With a filtering operation, you accept or reject elements in the array based on a Boolean condition. You don't know, going in, how many elements in the array will meet that condition. You could end up with 0 elements meeting it, you could end up with half the elements meeting it, or all of the elements meeting it. So the output array in size is between 0 and the size of the input array. You don't know where it's going to fall, right? So you have 2 options. You either pre-trace the array to see how many things are going to come out and then declare an array of that size and then populate it. That's how you do it if it's an array. Or B, you use a list and you delete the things from the list that aren't meeting the filter, and that's faster because you don't have to do the array twice. As you can tell, computer memory systems are something I'm personally very passionate about. For no particular reason, I just really like them. So on Friday we shall resume. You will have to endure more of me being excited about computer memory. I hope that that's not too much of a burden. Thank you and good evening.
Don't forget your camera.
Yes, thank you.